Hello everyone. Today I'm going to start with the reservoir dynamics and we will see the introduction of this subject, and afterwards we will see the basics of reservoir drive mechanisms. So reservoir drive mechanisms are the mechanisms due to which the fluid flows from the reservoir towards the producing well, and different types of drive mechanisms are defined or classified based on the availability of the dominant force in the reservoir. So we'll go to that part later, but before that, I'll just give you a brief idea about the different topics that we're going to cover under this paper. So under reservoir dynamics, we are going to study how fluid behaves while moving from one place to another place within the reservoir. By fluids, I mean oil and gas. So how oil and gas behave in the reservoir under reservoir conditions, and what is the mechanism of flow of oil and gas from the reservoir towards the wellbore, then how it is produced from the wellbore to the surface. So there are different types of mechanisms which are involved in traveling of oil from reservoir to the wellbore and then from the wellbore to the surface. Apart from that, we are going to see different reservoir properties and properties of reservoir fluids. Oil and gas behave differently under reservoir conditions, and their behavior is different at the surfacial conditions in the stock tank. Apart from that, we are also going to see some calculations where you can find out the volume of the reservoir. Once you know the volume of the reservoir, that is the volume of pore spaces in the reservoir, you can calculate what is the gas in place, or what is the oil in place, or what is the volume of water in the reservoir. Then when the production begins, certain amount of oil or gas is produced to the surface, and we calculate the recovery factor or unit recovery or gas remaining in the reservoir. So all those kinds of volumetric calculations are there. And apart from that, there are calculations associated with material balance equation. So here under this or these video tutorials, I will cover the theoretical part, and later on we can do the calculations based on the same. So when we say reservoir engineering, it is nothing but the art of developing and producing oil and gas or these fluids in such a manner as to obtain a high economic recovery. So we have to develop such a techniques of producing oil and gas from the reservoir where we can utilize maximum energy or maximum natural energy of the reservoir without utilizing any external source of energy. That is the first objective. Once the natural sources of energies are exhausted, we can look for other sources of energy from outside, which involves the secondary recovery or tertiary recovery mechanisms. So once the drilling procedure is complete, we start production, and in the initial phase of production, the objective is to produce maximum oil and gas by utilizing the natural sources of the energy. So this mechanism of oil and gas production should be obviously economically profitable. Then there are certain questions which arise while engineering the reservoir. We have to calculate the volume of initial hydrocarbons present in the reservoir. As I told you, the initial gas in place or initial oil in place. Then we have to know what is the amount of oil and gas recovered and what is remaining. So there are certain calculations associated with that we will see. Apart from that, we have to study what are the reasons or what are the sources of energies which are responsible for the movement of the reservoir fluids such as oil and gas from reservoir to the wellbore. Then which forces should be utilized in production of oil and gas. Now the energy is saved in different forms. We have to choose the best and most optimum source of energy so that we can produce longer at economically profitable rate. The incorrect selection of the production mechanism can result into the disaster. So we have to look at the various reservoir properties and energy available and then decide the primary recovery method. And once the primary recovery method is of no use, then we can go for secondary recovery methods by preparing certain strategies. So all these things are there. So we have to remember that there are no two reservoirs which are exactly identical in nature, although they show similar characteristics, and based on these characteristics, the reservoirs are grouped into different classes. But you cannot say that the two reservoirs or any two reservoirs are exactly identical in their nature in terms of reservoir properties, fluid properties, or any other conditions. So, what are the natural sources of energy in the reservoir and their characteristics that we will come to later? Before that, you need to know different classification or different classes of oils in the reservoir. And as it is shown here in this picture, you can see there are three major classes of oil: volatile oil, black oil, and heavy oil. Now, this classification is based on the molecular weight, and you can see the image also, and the scale is changing from right hand side towards the left hand side. So, volatile oil has molecular weight between, you can say, 40 to 70, and it is lighter, less viscous, and can be moved easily. So volatile oils may also contain some amount of gas dissolved within them, and as a result of that, these are energized and can be produced naturally. Whereas if you look at black oil is much heavier than volatile oil. The molecular weight ranges between 70 to around 130, and heavier than volatile oil. And finally, you have heavy oils having maximum molecular weight between 130 to 210, and the viscosity of heavy oil is highest, and they do not contain much of dissolved gas in them, and it is extremely difficult to produce these heavy oils naturally without applying any external force of energy. So apart from that, you need to know what is primary recovery. You can read the definition which is mentioned here. So primary recovery is the production period starting from the initial field discovery and continuing until the original energy sources for oil production are no longer producing at profitable rates. So primary recovery begins from the time when you puncture the reservoir for the first time, and when you puncture the reservoir, at that particular moment, the reservoir pressure is highest and you start producing naturally. The oil and gas will flow into the wellbore and from the wellbore to the surface as a result of high pressure or the release of high pressure. And for a certain period of time, you can produce without applying any external source of energy. Once that external source, once the natural source of energy is exhausted, we can go for artificial lift methods where pumps can be installed inside the wellbore, downhole, or we can install sucker rod pump. So all the artificial recovery methods are associated with natural recovery only. And after that, when there is no energy available in the reservoir to push the oil and gas into the wellbore to be lifted to the surface, the primary recovery is over. So as mentioned here, the primary recovery continues from the initial discovery until the natural energy sources for oil and gas are no longer producing at profitable rates. So once the natural energy in the reservoir is completely exhausted, we say it is the end of primary recovery. Then comes secondary recovery. So secondary recovery is the process which involves injection of fluids into the reservoir through various means, maybe through another well, and producing or energizing or re-energizing the reservoir to produce the remaining hydrocarbons. So we introduce either water or gas through another well into the reservoir to produce the remaining oil and gas in the reservoir. So repressurizing by gas or water flooding are the secondary recovery methods. Once there is no natural energy available in the reservoir, we go for secondary recovery. You can also see the image here. There are injection wells as well as producing wells. Water is injected through this injection well, either water or gas. When you are entering water, the water is injected into the aquifer, which is below. And when you are introducing gas into the reservoir, it should be injected into the oil to re-energize the oil, and that dissolved gas in oil will push oil to the surface through the wellbore, through the producing well. Now here in this triangular diagram, you can see the percentage or contribution of each recovery mechanism in the total production. The peak of the triangle is represented by primary recovery or natural flow, which is nothing but the uh, initial phase of production where artificial methods can also be utilized, and the contribution of natural recovery is 30% here. So different studies give different numbers. You might see that uh, certain authors and books say that the primary recovery is 10% or 20%. So it varies from uh, study to study. Second contribution is from secondary recovery 30 to 50%, and highest uh, contribution towards the production is by tertiary recovery methods. So you can just have a broad idea about the importance of these recovery methods. Although the contribution made by primary recovery method is very small, but you have to make sure that you can utilize maximum or complete natural sources of energy and then go for secondary and tertiary recovery methods to produce oil and gas at profitable rates. Now comes the types of reservoir energies in the reservoir. As mentioned here, the energy is stored in the reservoir in various forms. What happens is the reservoir is deep seated at hundreds of or thousands of feet or hundreds and thousands of meters depth. And as a result of overburden pressure, the rock or the reservoir itself is compressed. The fluid within the pore spaces of this rock, that is oil and gas, is compressed, as well as the water which is in the aquifer below is in compressed state. And when we drill a well and puncture this reservoir, the energy is suddenly released. The rock which has been punctured, it will expand to some extent, as well as the oil and gas, which are more compressible than rock, try to expand. And during this expansion, the gas which is present in the oil pushes the oil through the wellbore towards the surface, as well as the water which is below the oil and gas at the bottom or in the adjacent aquifer will push this oil and gas towards the surface. So the natural energy within the reservoir is stored in the form of compressed rock or compressed oil or compressed gas or compressed water in the adjoining aquifer, and also there is gravitational energy available, that is the natural tendency of oil and gas to flow towards the surface due to its specific gravity. So that also plays an important role in natural production, and these are the different types of energies usually available in the reservoir. So if you compare the compressibility of the three important factors here, that is compressibility of oil, compressibility of water, and compressibility of rock, you can clearly see the difference. The compressibility of oil is maximum here in comparison to water and rock, and obviously the compressibility of gas is maximum. So if you have to see the order of compressibility of different uh, aspects of the reservoir, the compressibility of gas is maximum, then comes oil, then water, and rock has least compressibility. Although it is least, there is minor expansion of rock upon drilling that can also contribute in the production. So this is the flow chart of different recovery mechanisms which are utilized in the production of oil and gas. There are various flow charts that we will see later on. So drive mechanisms, as I told you previously, these mechanisms are the ones due to which the fluid flows from the reservoir towards the wellbore, and type of drive mechanism is based on the dominant force of energy. So this part you'll understand when we begin with the different types of drive mechanisms. And it is important to recognize the possibility of certain kind of drive mechanism in a particular reservoir. Once you identify the possibility of presence of certain kind of drive mechanism, it is easy to produce that reservoir. Again, you can see one more flow chart. So there are different arrangements of these recovery mechanisms given by various scientists and companies. You have to just remember that there is a sequence. First is primary recovery, then comes secondary recovery, which involves injection of fluids such as gas and water, and finally tertiary recovery, which involves variety of mechanisms like chemical injection or thermal recovery methods or miscible fluid injection, microbial methods, and so on. Again, this is the diagram where you can see the different reservoir engineering aspects and the determination of hydrocarbon in place that you can see on the left hand side. That part we are going to cover under calculations, volumetric method of calculation of volume of reservoir, and also the material balance equation to calculate the volume of the reservoir, and different types of drive mechanisms which is shown here under determined reservoirs. So primary recovery phase, and then tertiary recovery mechanism is part of reservoir performance, which is in the next semester. So these are the reservoir drive mechanisms. You can go through them, and we're going to see each one of this mechanism in detail. Gas cap drive, or it is also called as free gas cap drive. Then comes solution gas drive, which is also known as dissolved gas drive. Then comes water drive. It is divided into two: bottom water drive and edge water drive, gravity drainage, and combination of these drive mechanisms. So these drive mechanisms are based on the dominant force of energy present in the reservoir. It is not necessary that in one particular drive mechanism only that particular source of energy is present. In case of gas cap drive, there could be water drive also, or in solution gas drive, gas cap drive can also play a role, but this classification is based on the presence of the dominant source of energy. So each drive mechanism has certain typical performance characteristics. Different graphs are derived based on the pressure and water or oil or gas production conditions. So we will see these graphs where you can see gas oil ratios or pressure decline curves, and then you can differentiate between different types of drive mechanisms. Now this phase diagram you have studied previously in geochemistry, and if you see this carefully, the x-axis represents pressure, sorry, the y-axis represents pressure, x-axis represents temperature, and this region is two-phase region where oil and gas coexist. So this line which you can see here, it is called as bubble point curve, which separates the liquid phase from the two-phase region. This portion of line or curve here, it is called as dew point curve, which separates the gas phase from the two-phase region. This particular point here, it is called as critical point, and you can say that when the temperature is lower than critical point, the reservoir is oil reservoir, and when the temperature is greater than this critical point temperature, the reservoir is gas reservoir. So this is all about the introduction part to the reservoir drive mechanisms. Next time we will begin with the different types of drive mechanisms.